Hey guys, this is Mr. Yo, and today we're going to talk about net ionic equation. This is one of the easier topics compared to the ones that we have went over in quarter two. And if you guys have any questions, feel free to come ask questions or send me an email in regards to these topics. And also, along the way, make sure to pause the video during the time when there is a question that you want to try out, or if there's any parts that I'm going too fast on, please make sure to pause the video. But let's go with the concepts now. So before we go on to anything related with net ionic equation, there are a couple things that I wanted to talk about. First thing first, you guys will probably see these two solubility charts. Okay. Solubility chart basically helps you determine either if one is insoluble or the other one is soluble. Now, what in the world does that mean? In the solubility chart, when we have these two parts, when one is soluble and the other one is insoluble, okay, that means soluble is something that is aqueous, okay? We sometimes call it AQ. Basically, what it means is that it is mixed with water, okay? While insoluble determines if it's solid, liquid, and gas, okay? Now, the very most important thing about these two is that in an aqueous solution, okay, they break apart. While in insoluble, they don't break apart. Okay? And I'll tell you more about that as we go along and as we discuss about some example problems. Now, before we go on to the things, informations, or on the net ionic stuff, we still need to understand how to use these tables. Now, my honors kids would be using this one, okay? And while my standard kids are using the one on the bottom, okay? So to understand how to use this is by providing you guys some example problems. For example, let's say that our example problem is Al I3. Is this aqueous or is this solid? So in a standard version, it's basically like the battleship or a battlefield. Okay, a lot of you guys have played a lot of board games, and it's kind of like looking at those. Or another example is like tic-tac-toe. First thing first, what we'll do is we'll focus on aluminum. Okay. While for the iodine, we have it right here. Now, what I'm going to do is I'm going to go all the way to the right, okay, and iodine all the way downward. Now, if we do focus on this, we can see that there is an intersection that's going on. And this time, AlI3 is going to be AQ, or aqueous, or we can call it as soluble. Let's try the other one. Now, if we look at our honors chart, what we can do is focus on iodide. So if we look at iodide right here, what we're going to do is we're going to make sure if we don't see any aluminum on the right side. So we have silver, lead, and mercury. None of these are actually aluminum, so that means if we look at the top, it's going to be soluble or aqueous. Okay? If this is confusing to you, I will provide you more example problems. For example, let's say NH4Cl. Okay? If we look at NH4Cl, so first thing first, let me erase all this. So NH4 is ammonium. So we're going to go look for ammonium, which is located right here, and chlorine, which is located right here. So if we intersect it, our outcome is going to be aqueous. Okay? Same goes with if you look at the honors chart, we will have the ammonium, or actually chlorine. Okay, so we're going to look for chloride. And we're going to check on the right side if there's any ammonium in there, which is not. So that means it's going to be soluble or aqueous. Okay, so the main part before we go over the net ionic equation is for you to understand what in the world or how in the world are we going to use this chart. So try to practice on your own. I gave you guys a lot of example problems in your homework assignment, and use those to answer these questions. Okay? So now that we kind of get to know what the chart is talking about, we're going to go and try some questions. So before I go over some questions, there are some rules that we need to follow. Step 1. So in the rules, step 1, make sure to balance our chemical equation. Okay? We have talked about balancing quite a while ago, but still it should be in your head. So try and if you guys have questions about that topic, please talk to me. Number 2 is determine, okay, if the compound is either aqueous or solid. Okay. Number 3, separate the AQs. Just the AQs, not solid, but AQs. And number 4 is for you guys to cross out the like terms. Okay, cross out the like terms. And last but not least, number 5 is to write the rest of the compounds. Okay. All right, so let's go on to one of the problem and see what we can do about it. So first question is CuCl2 plus AgC2H3O2 and CuC2H3O2 plus AgCl. Okay. So first thing first, we need to see if this is going to be balanced. So what we're going to do is make sure to write down all the common things that are shown on the left and on the right. Now, if you have a polyatomic ion that are the same, for example, we have the acetate and acetate, we're going to write it as it is. Okay. This way it will avoid you guys from getting confused on how to balance these equations. So Cu in the left side, we have 1, chlorine has 2, Ag is 1, acetate is 1. On the right side, we have 1, 2, 1, and 1. So I'm going to make sure that I balance this out. So I'm going to multiply 2 for the acetate, plug in the 2 here, and remember it distributes. So if you multiply 2 on the acetate, you will also multiply 2 on Ag. Now that we have 2 Ag on the left side, I'm going to multiply this by 2 as well. So I'm going to plug in 2. That means chlorine will also multiply by 2. And now that we see that each sides are all balanced out, we completed our first step. Okay. So now that we completed our first step, what we're going to do is we're going to make sure that we're going to figure out which one is aqueous and which one is solid. Now, using your table, pause the video and try to figure out which one is aqueous and which one is solid. Okay, so CuCl2 is aqueous. AgC2H3O2 is aqueous. CuC2H3O2 is aqueous. And last but not least, AgCl is solid. All right, so the third step is to separate the AQs. So this is where I'm going to split all the equations, especially the ones with the AQs. So we have Cu here and Cl. So I'm going to make sure I put a plus sign in each part. Ag, C2H3O2, and then Cu plus C2H3O2. And last but not least, our solid, which in this case is just as it is. All right, so now that we have all the AQs separated, what we're going to do is we're going to make sure that we have our charges and the same amount of each things. So Cu has a positive 2 charge. Cl is -1 charge. But remember to plug in that 2 in there because we have a subscript of 2. Ag, on this other hand, has 2 in it with a positive 1 charge. C2H3O2 has 2 as well because remember, coefficient basically means they will distribute. And it has a -1 charge. Then the charges will stay the same, so positive 2 or 2 plus. The acetate has 1 minus, but there's a 2 there, and so forth. So now this is, we just completed step 3. Last but not least, step 4, we're going to cross out the one that are like term. Now the key to do number 4, I would say, is look at the right side. Okay? It's easier that way because if you look at the right side, we can see that those that are separated are acetate and copper. And so I'm going to cross out copper, cross out acetate, and last but not least, our fifth answer, which in this case is 2Cl minus plus 2 Ag plus and 2 AgCl. This is called our net ionic equation. This is how we figure out our net ionic equation. So it's pretty much our review of everything that we have done, but with a little bit of details in the bottom. Okay? So now that we understood slightly on how to solve these questions, I'm going to provide you another example, and this time I would like you to do it on your own, and we will go over it together. So let me erase all the information, and here we go. So our problem is so try to solve this question on your own, and then we'll go over it together. All right, so now let's try to balance this out. Well, if you balance this out, the outcome of this will be a 3 here, a 2 here, and a 3 here. Okay? If you have not gotten these numbers, so what I would do is try to review it on your own again, just to make sure if you know how to do it, and see what's the mistake that you have done within balancing. Next, I'm going to make sure what our AQ is, or AQ and S is. So the first thing is we have an AQ, we have an AQ, we have an AQ, and we have an S. And as you keep on solving these kind of problems, you can actually see some relevance. In a net ionic equation, you will most likely have one solid, usually on the right side, but sometimes it can happen on the left as well. But that is some keys about net ionic equations. So if we do solve this out, what would happen? Well, now we got to split these up into two parts. So we have Al. There's two of those, so 3 plus charge, plus 3 SO4, 2 minus, plus 3 PB, 2 plus 2. Oops. Now this time there will be 6 in there. Okay, because if we distribute, it's going to have a 6. 3 times 2 is 6. Okay, 6 NO3 minus, which provides you 2 Al3 plus 6 NO3 minus, and plus our rest of our elements. There you go. So now I'm going to cross out the ones that are like terms. So obviously we're going to cross out those two out, which means Al and NO3. And then rewrite the rest of the compounds and elements. And your answer will become this. This is your net ionic equation. Okay? Now, there are times when there is no reaction, as in there's no solution. What does that basically supposed to mean? Well, let me give you an example. Okay, now that we solve these two types that relates with the net ionic equation that has a reaction, here's an example of when it does not have a reaction. Okay. So we don't actually have to balance this one because it's already balanced, but if we check on the solubility chart, you'll actually figure out that this is AQ, this is AQ, this is AQ, and this is AQ as well. What is that supposed to mean? Well, if we separate these, okay, if we separate these out, you might think, wait, is everything going to be canceled out? Well, it is. So if I try to cross them out, K, K, Br, Br, Ag, Ag, NO3, NO3, everything cancels out. So in this case, our solution is no reaction. Okay? So this is the only time when there's no reaction in a net ionic equation for double replacement. Okay? And this is the place where we stop for my standard students, okay? So I'm going to emphasize this is for my standards, standard chemistry, okay? If you're in my honors class, there is another concept which focuses on single replacement. Now, if you're in my standards, this is everything. So if you guys want to pause the video or go try your example problems, go for it, okay? And one thing also that I forgot to mention is that this is for double replacement only. Okay. Okay, so, or DR. So make sure to remember that. Solubility chart is for double replacement. Okay, so now let's go on with our next step on single replacements. Okay. So for single replacements, there are some things that you need to know before then, which is this chart. Now, how do we read it? Well, it's pretty simple. It's going by decreasing, or the top part is the greatest or the largest, while the bottom part is our smallest. Okay? There are some exceptions that you guys need to know, so make sure to read this part, please. Okay? Now, how do we solve this out? Well, let's say, for example, if we look at Li and Au, which one is greater? Okay? Well, we know Li is going to be the greatest because the largest is on the top. And what if we say, instead of Li, well, Ba. What would Ba do? Well, Ba is larger than Au because Au is literally here, and Ba is over here. Okay? So now that we know which one is greater and which one is smaller, let's try to solve some questions. For example, let's say we have Li plus Al2 SO4 3. Okay? Now for my honors kids, try to predict the product. Okay? So always make sure, first of all, is which one is positive and which one is negative charge. Okay? So, aluminum, we have a 3 plus, which you guys should know from your periodic table. And SO4 is 2 minus charge. Lithium should be a positive 1 charge or positive charge from your periodic table. Now pause the video and predict the product. All right, so now let's check it. So let's say aluminum will be by itself this time because why? Well, it's single replacement. The positive will always goes with the negative. So plus lithium 2 SO4. Because remember, the 2 is from the charge of sulfate. Now, is this a reaction or is this not a reaction? Okay. So basically from this chart, this activity chart, what we're going to do is check on, is lithium more greater in activity than aluminum? Okay, so lithium's here, and aluminum is right here. So we know lithium has greater activity, so switching place actually makes sense. So that means this is a reaction. But what would happen if we have a element that has lesser reaction or activity than the other element? So for example, let me give you another example then. So let's say that we have a equation of Br, okay, Br2 plus NaF. Now this might be slightly different because we just talked about metals. Okay, how do we deal with nonmetals this time then? So for nonmetals, what I'm going to say is check your electronegativity. If you guys don't remember what electronegativity was, here's a rough sketch of the periodic table. Electronegativity actually increases as you go top right and to the top. Okay, so somewhere over here. And so in that case, we know that, well, we have Br this time, and we have F. Is Br has greater activity than fluorine? Well, we know fluorine is our largest, and Br is below that. That means F is stronger, has more activity. And that also means that, well, you guessed it, there is no reaction. Okay. So there are some exceptions that you need to know of which makes a reaction and which does not make any reaction. So here's some review of what we just did today. Okay, we talked about the net ionic equation. And we talked about the soluble and insoluble. We talked about which one makes a reaction and which one does not. Okay, non-reaction, or I should say no reaction to be more exact. Okay, so here's the key point that you should know between these two. Reaction occurs when, okay, when there is one solid, okay, in double replacement. While no reaction is that everything gets crossed out. Okay. Next, in a single replacement, everything is basically determined, okay, this is actually for both, by its first equation. Okay. So if the reactivity of that lonely element, okay, is greater, then the reaction works. But if the reactivity of that lonely element is actually less than, then no reaction. Okay? So make sure to go over these notes. If it's still confusing to you, please make sure to come to me after school or during line time or send me an email so that I can answer your questions. Okay? So good luck studying these materials and have a nice day.